What is going on, Diesel Nation? We're excited to have you guys with us today on the Diesel Podcast. If you're watching this on YouTube and aren't subscribed, make sure and click the subscribe button, like, comment, let us know what you think about the episode. If there's a particular guest or topic that you'd like to have on, we're always checking your feedback on there and love to be able to get your suggestions onto future episodes. Today, I'm going to be joined by Matt from DFC Diesel, and I wanted to chat with him about the LML Duramax engine. There's a lot of questions, a lot of interest that I've heard from our listeners where they're wanting to know what fails either with higher mileage or with power upgrades, what they should expect if they're going to have issues with the crank, the cylinder heads, maybe other components inside the engine. So I'm definitely looking forward to chatting with him today, learning more about the engine, the weak points, and then fixes for them. Before we get to it, though, I want to remind you our friends at Kershaw Knives have a 40% off MSRP code for you, which we really appreciate them offering that to our listeners. If you use code 2024 Diesel40 at kershaw.kaiusa.com, it's a great way to save some money, get some really cool gear if you're in the market for a knife for hunting, fishing, EDC, something around the job site, around the house. They definitely got you covered with a bunch of different choices to meet any budget. And then you can also select different knives that have a different blade steel, blade shape, opening mechanisms. They got a ton of choices over there. So if you're in the market, head on over, use code 2024 Diesel40 for 40% off MSRP. All right, let's get to today's podcast with Matt from DFC Diesel and talking about the LML Duramax, the failures that it has, and then also fixes that he has for trucks that either worked really hard or that they have a lot of mileage on them. Welcome back to the Diesel Podcast. Matt, look forward to chatting with you, talking about engines, which is one of my favorite topics. I know our audience loves to hear about them as well. And I thought it'd be great to go through LML Duramax engines because there's a lot of them out there. They've got some mileage on them, or people are looking to get something and they're, asking, hey, is it a good engine? What things fail at different points? How can I upgrade it? And you'd be the perfect guy to ask. So welcome back to the podcast.
Yeah, thanks for having me. I know we've been trying for a couple weeks now, whatever, but our schedules haven't fully aligned.
They did today, though.
Yeah.
Walk me through the LML engine from your perspective, what you guys either see on cores or what customers or dealers are telling you about ones that are like in their shop or that have failed. Are there some common weak points that are in that engine?
Uh, Probably the most common failure we see is broken crankshaft behind number one main. After that, it's usually cracked pistons. Um, we don't see too many that are split right in half like the older ones did, but definitely a lot of cracks in the bowl and everything.
On the crankshaft, what causes that?
So there's actually a couple things behind that. So if you were to go back to like the LB7 LLY, uh, they had a lot lighter rotating assembly. And so Duramax engines, they're externally balanced, which means that the flywheel flex plate assembly and the harmonic balancer are actually what has the offset weight to balance the reciprocating assembly. And so as the engines got newer, the rotating assemblies like the pistons and rods got heavier. So they had to put more offset weight on the harmonic balancer and on the flywheel to offset it. And they have a fairly wide journal on number one, but a fairly narrow main bearing. And also the firing orders start cylinders 1, 2. So there's a lot of, stress right on that very first throw on the crankshaft, as well as having a lot more offset weight. So it's kind of a combination of the power is increased. There's a bit more offset weight to the reciprocating assembly, especially that's deflecting the front of that harmonic balancer, and then not having a wide enough bearing on number one journal kind of all contribute to it prematurely failing because it's almost always right behind number one main.
Now, one of the tough parts when we talk about failures, I was just thinking about this, is you might not know the answer with all the cores that are being sent in. But is it something that just happens with power, or can it also just happen over time? Because I think of somebody who owns an LML, and we're talking about the crankshaft or some of the other failures the engines might have. They'll think, oh, well, that's only on performance builds. Or is it something that'll happen on a bone stock truck after 300,000 or 400,000 miles? Is there any data or feedback you've gotten on what type of applications these failures happen in?
I mean, it really is. It really does lie with it. It is kind of a design flaw in a sense, because we see them happen on bone stock trucks. It would definitely increase the likelihood if you start increasing power to them. But I mean, you know, like I've seen builds where guys have put 1,500 horse to a stock crankshaft and they've lived, I mean, for I guess however long a period of time they're running that thing for. But then, you'll have the next guy that's completely bone stock, puts on 60,000 miles and it breaks. What is interesting though is like we magnaflux every single crankshaft because we're obviously inspecting to see it's like, hey, is it cracked? And what is interesting is like LMLs are probably one of our biggest selling engines for the past 2 years or so. And even though, so we build hundreds of these things a year, and what's interesting is very rarely do we ever find any that have a hairline crack in them, which is kind of to say that like if it was a crack that developed, let's say over the course of, 20, 30,000 miles, we would see lots come in that we'd be able to identify that crack.
Yeah.
But because of how rare one is actually we've been able to locate or diagnose a crack, and it means that when it does decide it's going to let go, it likely just develops the crack and splits in the matter of a few hundred miles. So it's a very small window, and it's just something I think happens out of the blue. Um, I don't I don't really think that there's any driving style or particular, horsepower setting or tune that would necessarily say, hey, it's going to guarantee it's going to break. Because I mean, there's hundreds of thousands of these things out there, and for how many that were built and how many, even though it's a more common failure, it's not like everyone's doing it. So
Yeah. I think if I had one of those trucks, I would be concerned because the window's so short, like you mentioned.
yeah.
So if it did happen to me, what would be my options to address it in an engine build? Are there things that I could request from you guys or we could talk about to alleviate that potential failure?
So we started offering it about well, I mean, we'd always offered them in kind of our tow haul HD builds, like our highest level of build, and then in 2023 we actually put them into our tow haul series. But because it is such a common thing, we actually have a model of both our long block and our street series, which is more of like our OE replacement level engines, where you can actually just order it where it comes with Cali's CompStar crankshaft. So they rate them conservatively at about 800 horsepower. And at least then it's like it's an upgrade that's like it's there right away. And I've yet to ever have one of them break on us. So it's usually for sure like, hey, if you upgrade it to this, you should never have this issue happen again.
Okay. Yeah, so there's definitely an option there to where if I had a failure, I could have it addressed. And I don't know a whole bunch about Duramaxes other than, I mean, I had one, I've driven them, I've talked to guests that have them. I kind of know the performance side a little bit. But when you have a crank failure, does it tend to wipe out other things in the engine or does it just tend to be localized to the crankshaft itself?
About 50% of the time it also creates hairline fractures in the number one main of the casting, the block. So pretty much every single, like when you tear them apart, they, to the naked eye, they usually look okay, but I mean, you got to really go looking for it. Um, but because of it, it's kind of like anytime one of the crankshafts broken, like even the driver, or even the owner of the truck could be able to diagnose it himself. Like if you crawl underneath the truck and just put your hand on the harmonic balancer, you can move it up and down a quarter inch. But like I said, it's about 50-50 where it's like we're able to salvage the block, but then obviously the crankshaft's no good. And that was running into problems even for us to be able to supply these engines because, we can keep on going out and buying cores, but we are ending up in a position where we're always short on cranks. So we had to definitely look at creating a consistent alternative that would allow us to sell these engines. So I mean, I think at any point in time we usually have like a dozen or more in of these LMLs or the other Duramax models in stock that have Cali's cranks already in them because it is a great upgrade. I think that a lot of people should look at if they definitely want to have the peace of mind that it's not going to leave them stranded on the side of the road one day.
When somebody's looking at a build, would you say that's one of the top upgrades somebody should do if they're doing a long block?
I would say, yeah, probably for like 90% of customers, that's probably one of the ones I'd recommend more than anything, especially on an LML.
Okay.
Like
I
I'd
think
recommend that ahead of head studs.
I think that's a lot of the questions that truck owners will face when they're looking at getting an engine is where, if they have some extra money, where should I allocate it? What should I do?
Mm.
Like you mentioned, head studs or I guess it depends on the build a little bit if they're going to do something else, but they like to identify where should I allocate upgrades in this build, and I think that's a great place to start. And you had mentioned pistons, and pistons to me, being a diesel enthusiast and reading and paying attention for a long time, that always seems to be something that we hear horror stories about. I
Mhm.
wanted to ask you with the cracked pistons is kind of the same question as the crank. Is that something where you think these trucks are tuned running more power, or is it kind of 50-50? It could be a bone stock truck and just a lot of mileage where you get a cracked piston.
Uh, I mean, I would say high mileage can definitely contribute to it, but I mean, more often than not, the most common ones is, uh, you know, even conservative, even a conservative increase in power, like I mean, where guys adding like 150 horse over stock, doing that and then towing a 20,000 pound trailer is not doing that engine any um any favors in terms of not cracking a piston, anyways.
Do
Uh, Sorry, go ahead.
is it are there options that you have like in the aftermarket in different pistons where kind of the same thing? Somebody has a cracked piston and they think, okay, I need to address this. Should I go back with stock, or what other options could they choose to be able to put into their build?
Like there's definitely a couple options. I mean, some of them we've offered in the past, and we're currently actually trying to get certification on some of them. So currently we actually like we were offering our tow haul and tow haul HD series engine where for guys that are looking for like a lot more horsepower over stock, those ones engines were upgraded with a Mala Motorsports piston. But we currently have those. They're not available to the US market right now. We've actually been working on getting some certification and stuff on a bunch of our engines and stuff because we want to make sure that everything we're offering is as good or better than OE sort of thing. The nice thing about the just sheer volume of engines we do is we do get to see some, I guess you could say, uh, experiences over time or whatever of kind of like what works and what doesn't. And to my knowledge, I don't like since we started using like our primary supplier of pistons right now is UEM, which is United Engine Machine, and they've been like an awesome partner for us. But I actually don't even know if I've ever even seen one of their pistons crack in one of our engines since we've started using them, and so we've been using it mainly in Duramax is probably since about 2019 or so, 2020. So we have about 3-4 years where it's like, for offering a, 100,000 mile warranty and stuff, and then just seeing like, what experiences are guys having. I mean, we seem to be having pretty good success with even their stock pistons. So in our long block and street series applications, I mean, I definitely feel confident that if someone buys one, they're not going to have any problems with it.
It's an interesting point you bring up about the different markets like the US. You guys are in Canada. There's different things that you guys can do in Canada with your trucks that here is harder or not able to be done.
Mhm.
But there, are there at higher power levels failures or different things you guys are seeing as the power levels go up on a truck that's in Canada? Maybe it's a performance build, street build, something like that in the LML. After we address, say, the crank, upgrade the pistons, is there something else that fails next?
Um, Well, so the Duramax does have like a couple areas that like always need addressing. Like, I mean, so on the crankshaft, I mean the pins that locate the gear that drives the oil pump as well as the camshaft, and then the pin that locates the harmonic balancer. I mean, they're only like about five millimeters or so wide and stuff. And so sometimes at higher power levels, both those pins in the crankshaft and even on the camshaft can break, and then you might have a cam crank synchronization problem and smash all your valves into the pistons. So standard on like all of our even like long block engines, I mean, we've always either added dowels to the factory crankshaft, and then we actually add in like a woodruff key on the camshaft. So then you go from a 5 millimeter round pin to like more of that like that half moon shape on the bottom, flat. It's kind of like a rectangle keyway that we put on the end of the camshaft. So then at least it's like it alleviates you're never going to have those issues happen. Back in about probably 2012, We were using like we were buying, I think, brand. I won't use a brand, but we're buying brand new oil pumps, and we actually had a couple where the shaft of the pump actually stretched. And the only thing that drives the gear on an oil pump of a Duramax is the clamp load of the nut. And so if the shaft stretches at all, then you'll actually have it where the gear can spin on the shaft, and then you lose oil pressure. So a lot of the upgrades we've done to our engines over the years are just based on, hey, the second we've seen a failure, is there anything we can potentially do to make sure it never happens again? And back around then, I mean, someone could have been doing it, but we couldn't find any examples. So we started using a machine shop local to us, and we started actually pinning the gear to the pump. And I know there's lots of places you can buy aftermarket pumps nowadays that have it where they put a pin right through the face of the gear into the oil pump shafts. That way it kind of keyways that gear to the shaft. So even if the shaft or the shaft did stretch a bit, it's going to keep driving the pump and everything, and you're not going to have a premature loss of oil pressure. Um, and those are just like little things we've always done for like I said, the last 10 plus years, just to ensure that, when we put these things out, I mean, that's not going to be contributing possible factor to them failing. So we are definitely addressing some of the um, I wouldn't say they're an inherent flaw in the engine, but they're definitely a weaker point for sure.
Yeah. Yeah, and I think with the power side of it, it almost exposes, or maybe not exposes, but it amplifies what kind of issues there can be in a design. And so I think of those trucks that get to 700, 800, maybe more,
Mm.
they're definitely going to find, some of these weak points quicker. My mind immediately switches to the heads and what sort of issues that they can have either with higher mileage, probably higher mileage, I would guess. But are there any sort of kind of inherent issues or things that you guys see on cores with the LML that says, hey, we need to address this in the valve train or the heads or the valves, the seat, all that kind of stuff?
Uh, Duramaxes compared to a lot of the other engines are actually probably one of the probably better lasting top ends out of all of them. Like like when you pull a set of heads apart that, sometimes even has 300,000 miles, there's usually pretty minimal guide wear because they have a pretty hard material the guides are made out of, and the valves are nitrided, so they're incredibly hard themselves. So they don't really get a lot of guide wear in them. And um, the seats, and because of the nitrided valves, they don't really wear out prematurely too much. I'd say probably the most common thing we see just in like numbers is if you're going to have a cracked head, it's almost always the passenger side. We've mainly just attributed it to it runs a little bit hotter because that's the side the EGR is on. So, I mean, if you're going to have it where it cracks at the base of the injector hole and leaks a bit of coolant past, or if there's going to be potentially like a crack in the cylinder head where it fails a pressure test, it's almost always on the passenger side head. But overall, they're a pretty well built head design that we don't actually see too many problems with. So
That's good.
the
That's
and sorry, actually to add on, probably the biggest thing you'd actually see, and I mean it was most common on the um, LB7, is just as they get really high mileage, because you have a steel gasket and aluminum face, is just over time the expansion contraction is you'll just start grooving the cylinder head. So that's usually what'll a lot of times create like a final head gasket failure. It's not so much the gasket finally failed, but it's actually worn into the aluminum enough that's bypassing a lot, and sometimes they'll even leak externally and stuff too, not necessarily just pressure up the coolant tank.
I was thinking about head studs because you'd mentioned those earlier and whether it be worth an upgrade. At what point would you say in one of either say a long block or short block, depending on what route somebody's going, when should they consider doing head studs on an LML?
Uh, I would say anytime you're planning on going more than about 80 or 100 horse over stock, probably a good thing to look into.
And that's part of I think that's part of an option. Like if I order a long block, I can get that with one of the setups that you guys have.
Yeah, like I know like we have some pretty unique part numbers actually. If anyone ever actually looks at our part numbers, you can actually tell what it kind of has the description of the engine built into the part number. So all of our part numbers go in like 2 or 3 digit increments. So the models that would come with, let's say, head studs would be our street series. So that part number would look something like SS for street series, and then 66 for the obviously 66 Duramax, and then 1116, so 11 to 16. Um, and then we'd go LML to make sure we say this is the actual model. And then we just go LB for long block or SB for short block. And then for the models that would come with, let's say, a Callie's crankshaft, on the very end of the part number, we add a CC for Callie's crankshaft. So I think I know a lot of our dealers and wholesalers really like that, because you can very quickly start figuring out, like if you're searching for something, just knowing what those acronyms mean, you can start typing it in and figuring out the part numbers really easily.
I'd love that if I was ordering parts. It'd make it easy for me. With one of the questions I like to ask, because I find there's a lot of new people who find the podcast and they don't have a diesel truck yet.
Mhm.
And they're looking to purchase one, and they might not be looking brand new. What is your opinion as an engine builder of the LML, comparing it in the Duramax family? Like if somebody, they're a GM fan, they definitely want a Duramax, but they're not particularly set on which one that they want yet. Do you think it's a good engine? Do you think it's more reliable, less reliable than other ones? Is it something that's a good platform to build off of? What would be your kind of consensus, for that engine?
Uh, feel like it's a bit of a difficult question to answer. I mean, like kind of systematically going through it. I mean, we do build the most amount of LMLs compared to every other Duramax model we've ever built. So we build more than the LMM or the LBZ, the LLY or the LB7. And like I said, the most common failure is the broken crankshaft in there. Now, try to look at things objectively though, is I don't know off the top of my head, how many LMLs are there in existence versus some of those other models, because it's like, well, we might build more if there's twice as many LMLs out there as there is some of the other models, then it's kind of unfairly saying that they fail more often. So, but you know what, like the thing about the trucks is, like, you know what, they start great in the cold, like most Duramaxes do, but as they got newer, it just got better. I mean, they make really, really good power. Um, Most people I've ever met that have LMLs, like, they just absolutely love the truck and everything. I know, I do later on, I do have a couple of good stories about some of the speed of air testing we've done in LMLs that had really good results.
That was, I'm glad you brought that up, because after our last chat, a lot of people wanted to know more, and there were comments to, we want to know about the testing or tell us more about it. So what kind of feedback did you get with those pistons? And for anyone that didn't catch the first episode, if you could maybe explain a little bit about those pistons and the testing that you guys are doing for them, so they get caught up to the listeners who heard it before.
Yeah, so the pistons are from a company called Speed of Air, so they have a patented technology that we've licensed. We're offering it in obviously all of our Speed of Air series engines, but they put kind of these different patterns and stuff into the crown of the piston that are called turbulators, but they look very similar to kind of dimples of a golf ball, but they're very strategically placed and have a lot to do with the combustion process. But at the end of the day, it's creating it where you're creating a lot more turbulence in the cylinder bore, so it's allowing the engine to burn more of the leftover fuel, and that allows it to get better fuel economy. You have less soot in the oil. The truck makes considerably more low end and mid range power than it did before, and it increases the peak horsepower and torque. I mean, we've been finding in every example, it's dramatically lowering emissions, like it's lowering NOx, it's lowering carbon and stuff out the tailpipe. And even some of our long-term testing, it's dramatically decreasing how often trucks are regenning even. Like, I mean, I've had 6, 7 Fords recently. We put engines in where in the 5,000 miles before the engine, on a truck with 187,000 miles, it'd regen 20 times. And after the engine, the next 5,000 miles, it ought to regen 6 times.
That's a big difference.
So it literally check marks off the box in every single positive way you can imagine for it. And um, so yeah, we're actually doing some testing on an LML right now, and hopefully in the next month or two we'll be able to fully share all the results. But I mean, it's it's kind of wild when you actually like bolt in another lawn block and you didn't change a thing. Everything's stock airbox, stock exhaust, everything. And like I'm not even the owner of the truck, but when I hop in it and you notice a dramatic difference in power, and then you put it on the dyno and the LML we did, we saw it at some points of the RPM, we actually saw it pick up well over 200 foot-pounds of torque compared to the stock engine.
Wow, that's that's a pretty big difference.
Yeah.
For everything else being
And
stock and just the pistons.
because I mean, I remember driving it and it was one of the first LMLs I'd ever driven and I drove it stock. And then after we put the engine in, and I'm just like, man, like this thing moves. Like I was impressed as like, I mean, I almost feel like the thing was like a crew cab short box, 3/4 ton 2015. I mean, I feel like it would probably outrun one of the brand new L5Ps.
Do you think like a lot of the questions that we got or the interest that I found from it was that it applied to a stock truck or something close to stock. It wasn't just a race application. And in my mind, when I think of pistons and I think of an engine build, it was always materials or a size or something that was being done basically just to handle the power you were throwing at the truck.
Mhm.
It wasn't something that I could just do on a stock or like a truck I'm using to tow with to get those kind of benefits. And it's been, my perception is just a huge change in the way that enthusiasts think about internal parts on the engine. It was always about, can it handle this power? Do I need billet rods? What do I got to do to the crank? Do I
Yeah.
need head studs? Do I got a fire ring? It's just to handle what you're throwing at it versus it actually having a result in power and torque and fuel efficiency and emissions output.
Yeah. Well, I mean, and like I've obviously been in this industry for a long time too, and back in like the mid 2000s, especially up here in Canada, it just seemed like every day that some of the shops I worked at before I started DFC were coming in and like, hey, how do I make my truck go 12 seconds a quarter mile and stuff all the time, and but it is kind of crazy how when you look back at the early 2000s, so many people were like, well, if I only had like 400 or 500 horse and 1,000 foot-pounds, that'd be all I ever needed. And now we essentially have that with the new trucks. And I mean, don't get me wrong. I mean, I love add it. Like I can't leave anything alone. Like everything I have is modified. Um, but more than anything is I think people are looking for like um how do I get like the most life, mileage, use, value out of their trucks? And no one likes being broken down or anything. And I do believe like around that 400 or 500 horse and 1,200 foot-pound mark. I mean, we're getting to the area where at least now when someone hooks up to their 15, 20,000 pound trailer, they can maintain speed on virtually any hill. And that's usually I think what would always drive people wanting to get more power and stuff is like no one likes losing, 10 miles an hour up a hill. So got to be able to either maintain speed or accelerate, right?
Yeah. Yeah.
and
That's, oh, go ahead.
and then yeah, so I mean it's like now that we're kind of getting that out of the OE, I mean, I think that's where, as these trucks have gotten more expensive, I mean, we're gonna have it where like they're not just gonna go to the auto or to the junkyard or auto wrecker unless they've been in an accident. So I mean, people are gonna want to like, hold on to these vehicles for longer. And so when the time does come that, you need an engine, I mean, out of anything that we would sell or offer, I mean, that speed of air series is just it so dramatically changes in positive ways how the truck just drives in general. Like everyone's just been absolutely in love with them. Like I think, we probably have about, I don't know, probably 40 plus customers so far that have gotten them in the last, 6 months or so, 6, 8 months. And, every single person's just like the feedback's always like, well, I heard you say all the things, but I didn't think it'd actually work as good as you said it would. And I actually had a customer with another LML in the US not long ago sent me an email and he said he had, he's still idling a lot, so he hasn't been able to get the fuel economy increases. But his email was just summarizing that for the equipment he was towing, he's just like the truck's not downshifting anymore on a lot of hills. It is noticeable more power, it's quieter, like everything you said, it's actually experiencing.
Is it something you're finding in the marketplace people are becoming more receptive to, maybe because of the past, how in the past there would be a product and we would see it in a magazine or see it on a video or read it on a forum and somebody would say, hey, this made a world of difference. It was really hard to put the data behind it or qualify it.
Mhm.
And so they became skeptical, because I find there's a lot of skepticism across anything
Mhm.
in automotive. But people, because of those engines out there, because of the testing and the data that you're doing, it's easier to validate it, because I found that was a lot of the feedback we would get was, well, does it really work? Or people tried this in the 80s on this particular gas vehicle. You know, does it really provide all these benefits? And that's what I enjoy about these conversations, because you're there, you're looking at the data, you're talking to the customers, you're seeing the trucks. So it's a firsthand account of the benefits or the upgrades that these trucks are seeing.
Mhm. Yeah, and no, I'd definitely say, I mean, like, and rightfully so. I mean, there's been a lot of products over the year that, like, I think a lot of times when salesmen get involved with things, and I mean, I don't consider myself a salesman. Like, I'm a very like you know, logical, rational person, and I always try and talk in actual like facts and data and stuff. But I find that, because I'm actually using that to support it, that, I do a good job in sales when I do have to kind of put that hat on. Um, but that was a big thing, is like, again, when I first met the guys from Speed of Air, I remember leaving the meeting with them, and I was like, man, like, these are all very intelligent, passionate people about this, and like, these are some pretty bold claims they're making. And I you know I myself was rightfully skeptical, but as is like, what, they were so consistent in everything they were bringing it up. I was like, what, I got to try this myself. And I wasn't going to rely on someone else to go and do it. So I mean, we also ourselves have just about like, I mean, we have, I think, about 25 trucks in some stage of testing, but I mean, I think we have data on probably like 16 or 17 of them, like complete data. And that also includes where we took a perfectly good running truck and all we swapped is a lawn block. So I mean, we did emissions data beforehand, we did mileage data for 5 or 10,000 miles, we did oil data testing, and then we literally just swapped the lawn blocks. So same injectors, tune, turbo, you name it, swap it, and then see what are the results afterwards. And then right now we're still going through the process of then pulling the engines out after they've been run for a period of time, and then taking photos of even showing, like, well, look at how much less carbon and soot buildup there is in the crown of the piston, and even in the ringlands and stuff. And I mean, that's even helping to support saying, when you have, like, let's say a regular engine that gets built and after 20,000 miles, there's like this like 1/8 inch thick buildup of soot on the ringlands and on the crown of the piston, and then you pull a speed of air one out and you wipe it with a rag, and it's almost bright white still. It's kind of crazy.
Yeah. Yeah, and I know there's going to be people listening that have a Power Stroke or a Cummins, and I wanted to ask you more generally with DFC, with these pistons, are they incorporated into all the builds, all the engine builds, or is it certain models that you guys are focusing on? Or if somebody has a truck other than an LML and they're interested in it, what do you guys offer currently?
We currently offer them for everything. So 6 liter, 6.4, 6.7 Ford, 5.9, 6.7 Cummins, from the 12 valves all the way up to the 2018 Cummins. And then all of the Duramax and stuff. I mean, a lot of the talks I've had with them, like, so the one thing that I will be honest about is we haven't done a lot of testing in, like, let's say, applications over about 500-600 horse. I would feel 100% confident to put these engines in 1,000 horsepower application in, let's say, like a Cummins 5.9 or 6.7 in a 6.7 Ford. But I am a bit nervous about how much power they would hold up to in like a 6.4 or a Duramax application. And the only reason I say that, it's not based on the technology, but it's because the inherent design of the pistons in those years is, once you exceed, let's say, like 500-600 horse, they're susceptible to cracking from factory. So unless you use a a different design of piston that helps alleviate that. And to better describe it, so a lot of viewers and other people, they've probably seen it where, you have a piston that actually cracks in half across the wrist pin. And so one of the primary causes of that actually is when you increase the timing of an engine, that means that you're spraying fuel into the bowl when the piston's further away from the cylinder head. So when you start doing that, you start actually trying to kind of force the piston through an explosion where you're starting to load up the outside diameter of the piston more. And it creates a really strong wedge effect where it'll try and actually force the piston around the wrist pin. So those pistons are cracked in half across the wrist pin actually originate where the crack is actually at the top of the wrist pin and comes from the bottom up actually. And so the reason why it's most common to happen in, let's say, like the 6.4 engines and the Duramaxes is because um, for the diameter of the piston versus like how tall it is, like when you look at a Cummins piston, they're like, 4 or 5 inches tall. So they have a lot of material to them. So they can just take a lot, like even if you have really high timing or a high wedge effect, I mean, you're not risking that happening. But because there's a lot less material on the Duramax and 6.4s, that's why um, they're most likely to crack. And again, it's part of the design. So I mean, if you take a 6.4, for example, I've seen guys crack the factory pistons in half with like an extra 7,500 horse tune over stock. But I've seen the same piston that if you chamfer the bowl out of it, so you help remove that wedge effect, they've taken 1,300.
So it comes back to that design.
Yeah. And so going back to the speed of air, it's like the speed of air itself doesn't negatively affect the strength of the piston one bit. I can't really go into details as to why that is, but it's just more of it's like I wouldn't any customer would be looking to put these into a high horsepower application in those applications I said, like I said, the 5.967 Cummins or the 6.7 Ford. They're going to be more than capable of taking that, but we're still doing some more testing with some different designs to help reduce that wedge effect. But at the same time as we want to make sure that anything that we design or create with UEM and speed of air's help or whatever is that we're actually creating a piston that is still going to be better than OE also from an emission standpoint too. So
yeah, I think it's a very varied sort of market in that probably 99% of the people are close to that are going to be looking at that 500 to 600 tops. Yeah. And they're using the trucks hard. But then there's that 1% to 2% where they're going to take it a lot farther. But I think that comes back to the design and making it specific towards, is this truck at 800, 900, 1300, 1500, what it might be, which I think we're kind of used to in a way because we wouldn't buy race pistons to put in our daily driver. Yeah. Or run, stock pistons on something that's, high power. So I think maybe as time goes along, that might evolve into being able to offer that. But I think for the guys that are stock or near stock or running like a tow tune or something like that, that would be such a huge benefit to add to a build. I would want it. I would definitely, consider an upgrade like that for just using every day.
I mean, whenever you need an engine, we'll talk.
That's one of those things too, where like I want an engine, but I want to do it when I'm ready versus, oh man, I'm stuck on the side of the road. I just broke this or I broke that and it's down. Yeah. And I know a lot of guys get in that position, which is why I wanted to ask you about, the upgrades and which one should we consider, because I think a lot of people, maybe most of them, it's just this catastrophic failure that happens and they're just in a bind and it's something they didn't plan for. They're thinking, well, while I'm in there, what should I upgrade? What is worthwhile? And it really helps, I think, your description of what potential failures are in an LML for those people who own them to think about, the crankshaft, the pistons, what other things, should I look at doing so they get a solid setup. And I'm sure we could spend hours and hours and hours talking about probably just the crankshaft or bearings or pistons, but it's really cool and it helps me learn as well to be able to understand.
Well, and actually something else I'd like to add on the crankshaft and again, like this is just from what I've seen. I mean, other companies could very well be doing this. I've never seen it or seen it advertised or talked about. But so the factory Duramax cranks, they're actually they have like this nitride hardening on them, and it's only about 1 thou or so thick. But it kind of makes like the counterweights and the rest of the crankshaft have kind of like this off green color. And so when we're rebuilding the engines, like I've always had kind of a criteria of like, rebuild the engine like someone's going to take it apart and criticize it, so I want to have it where it's like our engines look as good internally where no one sees them as it would look from the outside. And in a lot of these cores we're getting back is the as they've gone up their mileage, we're getting them back where they have like, some scratches or gouges in the surface of the crank. And, from I don't want to, what I'd say is like what's recognized in the general industry is that these scratches and dings that may, or I don't want to say dings, but just more like these grooves or scratches that are in the crankshaft journals. I would say probably like 99% of other shops out there, they would just polish it and it'll be like, oh, it'll just hold oil and it'll be fine. But because of how strict I've always been on trying to, let's make sure we're doing the best we possibly can, as if there's any sort of burrs, deviation, anything on that. So then we'll grind it to a 10th oversize. Now, what happens with that is once you grind the crank and you get through that nitriding, the hardness of it dramatically drops. So you'll go from, let's say, like 45 Rockwell down to about 25 Rockwell. So then what we have to do is we actually send them out and we get them renitrided again. And we found actually another company that their process, when they nitride, it actually gets about 6 thou deep into the material. And so it actually turns the crankshaft black after it's been done. So then we have to essentially grind it, polish it, make sure it's all within spec and everything. And then the nitriding can sometimes add a couple of tenths of thickness to it. So we have to obviously adjust for that when we're grinding it and then send it out. And, after it comes back, we still have to obviously inspect it, make sure it's still good, then repolish it. And then that leads into the next thing where, there's just so many bearing failures out there in pretty much Dodge, Ford, Chevy, like you name it. Like there's a lot of bottom end failures that happen, and so much of those failures can, potentially be prevented just by having the correct RA finish on the crankshaft. And I've found that like a lot of companies, like they'll have a procedure and they'll just like, all right, yeah, it looks good. This way we've done it for 20 years sort of thing. But you do actually need like a profilometer to actually measure what that surface finish is. And like in diesel or high performance applications, you're supposed to be under 10 RA finish, and we're typically aiming for about 6 to 8 as kind of a minimum standard, because that'll just help maintain that oil wedge that supports the load on the crankshaft and everything, and prevents premature wear of that bearing. I know we had talked about, like, I could probably talk about this one for another hour or two, but just kind of touching on that's one step that we actually do to every, like probably 80% of cranks we end up having to grind because there's some type of, defect or something in the surface of it. And so that's something that's actually like, I still feel like we're adding value to the customer, because I think there's a lot of one of two things. There's either a lot of crankshafts going out that have these burrs and these grooves in the crankshaft, or they're being ground, and if they're not nitrided, they're a lot softer, which could potentially lead to a premature failure down the road too.
I think what we should do is have another talk and just focus on surface finish, because there's so many questions I know our audience is going to have, that I have about it, and it's such a huge topic. We should spend some time going through that and understanding these smaller details, because that's important. Like I would want to know that would make a purchasing decision for me, knowing
Yeah.
those small details. So that's something we'll definitely have to keep in mind. I really appreciate your time chatting with me about this. I have a bunch of listeners that have wanted an LML specific kind of episode on what they need to build. So I appreciate your expertise and sharing that knowledge with us, and look forward to being able to sit down with you again. And I think we should do surface finish next.
Yeah. Yeah. No, like I said, yeah, didn't even realize how fast the time went by today, but yeah, no, I think that'd be a really good one, because there's so many important surface finishes throughout the engine that have to be addressed if you want to have like, like, I guess kind of like I think I talked about one of my previous one is, when you try and offer, let's say, like a 5 year, 100,000 mile plus warranty, it constantly pushes you to look at things that might come back after 4 years, 5 years. We even have customers that, like, hey, something happens 7 years later and they're like, hey, is there anything you can do for me? And we want to make sure that we continue to maintain that relationship as a customer. So, um, paying attention to those things, like, hey, if we push it to this level, this is how much more life we can get out of it. We're always up for, like, hey, how do we continue to raise that threshold and try and make it where the engine will outlast the truck, sort of thing. So
Well, I appreciate you chatting with me today, Matt, and I always look forward to our talks. And I learned so much from them, and then it gets the wheel spinning for other, topics and questions. And it was really cool to learn about. So I appreciate you taking the time today to chat with me.
Yep. No, you as well. Thanks, Patrick.
Don't forget, Diesel fans, make sure and head on over to Kershaw.kaiusa.com. Use code 2024 Diesel40 for 40% off MSRP. It's a great way to save some money, get some really cool gear. If you're in the market for a knife for hunting, fishing, EDC, something around the job site, they have a ton of choices for different blade shape, different blade steel, opening mechanisms, different handle designs. So if you're in the market, head on over, use our code 2024 Diesel40 and get 40% off MSRP. Also want to give a shout out to some of our Patreon supporters, Tyler Loewen at 23 Diesel, John, J Cole, all of our other Patreon supporters, all of you who subscribe on YouTube podcast apps, follow us on social media. We appreciate all your support here in year 8 of the Diesel podcast and look forward to bringing you more of the content that you guys want to hear in 2024. Till next time, keep the shiny side up.